Hello, I'm Brian Carlson. I'm the Operational Excellence Lead for the AWS Well Architected program, and I'm here today to talk about building a robust monitoring strategy. In my role, I research the operations best practices that enable customer success, and I develop and share those best practices and design principles to support our customers effectively and efficiently supporting their own workloads in the cloud. Today's talk is based on those best practices and design principles. When we talk about strategy, I'm talking about a plan to achieve an outcome or a method. And when I talk about robust, I'm talking about capable of working under a wide variety of conditions with some uncertainty. So for today, our strategy is at a high level, and it's a high level approach to the problem, and our plan is the specific actions we're going to take to accomplish the goals of that strategy. Now, I am from the Well Architected team, and Well Architected is a free set of guidance applicable to the cloud, hybrid environments, and on-premises workloads. It was created in 2012 as a response to challenges that we saw our customers having. And in 2012, it focused on security, reliability, performance efficiency, and cost optimization. Now in 2016, the operational excellence pillar was added because we recognized that our customers were having challenges, and we wanted to provide them the resources necessary to assist them in addressing those concerns. There's a wealth of other resources inside of Well Architected, including the Well Architected tool in the console, and it's all free to use. So where are we going today? Today, we're talking about monitoring strategy, and we're going to talk about why, what, how, and we're going to focus on the people that will be consuming our insights and understanding their needs, understanding what the business is trying to achieve, understanding what good looks like, informing decisions, and enabling people to take action, and then we're going to take a lightweight approach to defining criticality. All right. If we have a strategy, we have defined our goals, and we can check to see if we've been successful. If we have been successful, we can continue to improve. If we haven't been successful, we can revise our strategy, make adjustments, iterate, and seek to improve. The first and most important question in all of Well Architected is the first question in operational excellence. Paraphrased, it's what are you trying to do and why? It's the most important question because the answer shapes everything else you do and informs all your decisions. We are developing a robust monitoring strategy to ensure that business and operations teams have the insight they need into the applications that support the applications and workload that support the needs of the business. Effective monitoring will help customers gain situational awareness. It will enable them to be proactive in order to prevent issues from occurring, and when issues do occur, it will help them to respond effectively, reducing the impact of incidents. Ultimately, we're going to help achieve business outcomes. We're enabling informed decision-making and timely action in support of the achievement of those business outcomes. And when we're finished today, you will understand how a monitoring strategy supports these goals, and you'll have a practical and relatively simple approach to developing your own. Let's do a check for signs that monitoring challenges are emerging in your environments. Do any of these apply to you? If you're in the green, these are generally good and timely questions. If you're in the orange, it's time to have some direct conversations. And if you're in the red, take action and get engaged, especially if the same issues are recurring in production. As we implement our monitoring strategy, we're going to develop a monitoring plan. Without a plan, we can't evaluate whether or not we're monitoring the right things. If we were monitoring the wrong things, we might be obscuring actionable data behind unnecessary data and making it hard to understand the status of our workload. If we're monitoring the wrong things, we may miss the opportunity to take action when outcomes are at risk. And we will apply our strategy to developing our monitoring plan because it will define what we measure, it'll define how we measure it, and how those insights will be used. All right. So we have a strategy, we define goals. If we're successful, we can continue to improve. If we aren't successful, we can make adjustments, iterate, and improve. We can. A monitoring strategy is based on the information lifecycle. That is, data is collected, and when context is applied, it becomes information. The information is correlated to create knowledge, and with analysis we can gain insights, and from insights we can guide actions. We're going to take the expertise of people and their knowledge, along with system architecture, and combine those into the plan, along with telemetry, that is the collection of data and the measurements from the instrumentation within the components of our system. We will take telemetry from our full stack, and when I talk about full stack, I'm referring to the application, the infrastructure, the resources, the services that all support the workload from which we're collecting, and all those sources are from where we're collecting data. There will also be insights that are categorized based on the needs of the business and that are identified by the stakeholders. And the monitoring plan will also include what actions must be taken based on the insights gained in the workload. Later on, we'll talk about alerting, and if you're going to alert, there needs to be an action behind it. In the next section, we're going to take a quick look at categories of insight, and then after that, sources of insight, telemetry, but we'll revisit both during our development of our monitoring strategy. All right, FCAPS. FCAPS is the ISO standard for network management. The acronym refers to Fault, Configuration, Accounting, Performance, and Security. Now, FCAPS is a bottom-up approach looking at individual components, and it's a useful tool to start the conversation, and insights about individual components are useful, but they are not enough on their own. With faults, we're monitoring to identify an impending incident so that action can be taken to avert it, or we're monitoring to identify active incidents so that action can be taken to address them. We're asking the questions, what might go wrong and what has gone wrong? With configuration, we seek to identify when unauthorized or incorrect configurations are present so they can get corrected. We're asking what has changed and has it changed appropriately? With accounting, we're tying utilization to the organizations and individuals. This could be for chargeback to make users aware of their utilization. It could be for showback to make them aware, chargeback to recover costs, or it might be related to supporting billing in a multi-tenant environment. The question we're asking here is, who consumed what? With performance, we seek to understand the efficiency of our workload and its components in order to target improvements. We also want to understand the impact of changes, both good and bad, on the efficiency of the workload, and to evaluate the effectiveness improvements we make. The questions we're asking here is, how's it doing? Do we need to make improvements? And have our improvements been worth the investment? With security, we're monitoring the effectiveness of security controls implemented in support of our security policy. We're also identifying inappropriate and potentially malicious activity to support its investigation and enabling effective responses. The question we're asking here is, who did what and was that okay? Now, with all that, it's not enough. If we can't determine if we're being successful achieving business outcomes, what have we accomplished? Anything we monitor should be traceable back to how it supports a business outcome. The path might be complicated and obscure, but if we're doing something that doesn't support a business outcome, we need to ask why. So pulling that all together, we have faults, configuration, accounting, performance, and security, but the heart of it is we need to understand the achievement of business outcomes. All right. Now, beyond those categories of insight, there are some advanced ones. We would like to understand our user behavior. That is, how they use the application, how they use the workload. Things like clickstream data can be extremely helpful, and they can give us a lot of insight. If we deploy a new feature and it isn't getting used, why is that? Can we identify if the signposting is bad? Can we identify if it's difficult to use and customers are abandoning transactions? Perhaps they just don't care. Maybe this is a feature that was a bad choice and we shouldn't put further investments into it. If we can get insights to our user behavior, we can make informed decisions about what we do. If user behavior changes abruptly, like if we have a retail site and the order rate drops abruptly, out of expectations, outside of a historical perspective, well, it might be an indicator of a different problem. In fact, a drop in order rate might spot the problem before any other indicators do. And that's an example of anomaly detection. We want to take the same approach to understanding our workload behavior. We want to be able to investigate when telemetry is outside of our expectations and historical trends, and this is yet another example of anomaly detection, using it to prompt action. So, from there we go to sources of insight. That's our telemetry. How are we going to learn about these conditions? Well, logs tell us whatever the developer decided they would. Logs are the events that we receive from applications, and they're useful for uncovering emerging conditions, events that happen prior to an event, events that happen prior to an incident, and unpredictable behavior. So if we're getting an odd series of events that's unexpected, we're probably going to get behavior behind that. If a resource is unhealthy, a log will probably help us answer why it became unhealthy. Metrics really have two flavors. There's metrics that are calculated based on the number of observations of a thing. We could look at the number of times a log occurred and in a period of time and use that as a metric for indicating what's going on. Or it could be a value at the point in time which a measurement was made, like CPU utilization, for example. Metrics are useful for identifying trends and performing mathematical modeling for prediction. If a resource is unhealthy, metrics are likely to indicate that and may allow you to also predict when a component may fail. Traces are representations of series of related distributed events. They're collected end-to-end as a request flows through a distributed system. It gives us visibility in both the path traversed by the request and provides insight to the health of all the components it crosses over. Traces are really great for getting insight for how a transaction moves across your workload and even discovering the relationships between individual components. Now, that's 3 different sources of telemetry. And what we're trying to achieve is an effective level of observability. The goal of observability is to enable rapid identification of unknown issues to reduce the time to recovery from an incident. Observability is a measurement of our capacity to understand our workload. So bring it together, logs, metrics, and traces, when used together, when you can correlate them, when they're used in unison, they provide the maximum visibility into the behavior of the system, and they enable observability to help us identify contributing factors to an incident that we did not previously understand. So this is what observability looks like at AWS. We have our foundations, CloudWatch logs, CloudWatch metrics, X-ray, traces, and there's CloudWatch alarms. And then above that, we have some enabling services and features. CloudWatch Service Lens allows you to do aggregation and correlation. Anomaly detection, composite alarms, and log insights are tools to get more out of your telemetry. Anomaly detection, of course, identifying when something's out of expectation based on historically observed data. Composite alarms allow you to get a system-level view. Instead of having a single component alarm, you can set up the logic so that a set of conditions must be present, a system-level view, before an alarm is raised. It's kind of like thinking if you have multiple domain controllers, if one of them fails, is it an issue? If 2 of them fails, is it an issue? If 3 fail, that might be an issue if you only have 3. Log Insights is a tool for rapidly analyzing your data. It's a query language for querying your logs, structured. Container Insights, well, that's domain-specific insights to containers. Contributor Insights, similarly, is about stream data and understanding how contributors are impacting its load. And then there's CloudWatch Synthetics, which I believe is one of the unfortunately least used capabilities out there. Synthetics allow you to take a human interaction with the system and test it. So if there's an interface for a human being, you can, well, there's actually a tool to record that activity and then replay it to confirm the functionality. So you can record canaries for all the transactions a customer might execute, and then play them back to confirm that they're all functional, say after you deploy a change. At the same time, you can use them to determine if there's changes in performance. You can put all these transactions into a single canary, and the free tier would allow you, if you're deploying infrequently, to do this all for free. I think CloudWatch Synthetics is underutilized. All right, so what's the difference between monitoring and observability? Observability is something you have. Monitoring is something you do. Monitoring can tell us something is wrong, but may not always be able to tell us what is wrong. When this happens, we use observability to research and discover the contributing factors so we can mitigate or remediate the issue. And when we do encounter something new, we want to take what we learned from observability and update our monitoring and our procedures for responding to those events so that we can recognize emerging conditions and respond appropriately and faster. Monitoring asks, are we good? And ideally is able to answer that question as well. When it can't, observability asks, why aren't we good? And seeks to answer. All right, let's build a monitoring strategy. Here's our approach. This is specifically an overview. There's a lot going on here, and we're going to go into all the parts in detail in the following slides. Let's start out looking at it from the OE pillar. The OE pillar has 4 focus areas: organization, prepare, operate, and evolve. In organization, we focus on your organization, your requirements, how you're structured to support your business outcomes. In prepare, we look at accelerating the flow of beneficial changes into production, but that includes testing before things arrive in production, and that testing should give us information about how it should perform. In operate, we're monitoring metrics for both the workload and our operations activities that we perform, and trying to identify if there are issues in the environment. When there are, we respond. We do incident event management, and ideally, we learn from that, update our procedures, update our monitoring, and improve our workload. We've got to have these feedback loops working so that we can continue to improve. Monitoring is not one and done. Monitoring is a continuous cycle. You want to keep improving. All right, so how does that overlay the activities we're going to perform? Well, we're starting with people. We're starting with who are the people who are going to consume our insights, and what do they need? It starts with people because someone's going to consume the information. Then we look at the needs of the business. The people are representing the needs of the business, the outcomes we're looking for. We look at the goals of those outcomes and try and map them to key performance indicators. Then from the key performance indicators, we try to map to something measurable coming off the workload or our activities, our metrics, and we establish thresholds to evaluate if we're good or not. And when we are not within those thresholds, we take action and we respond. So, who are the people we're going to provide insights to? There's lots of ways to look at who your monitoring customers are. Let's start by thinking of them in terms of internal relationships, external and managed relationships, and external obligations. Internal systems supporting the business will have internal customers in need of insight to those systems and their use. Externally facing systems will have internal consumers in need of insight as part of their management of the system, their support of their external users. Externally facing systems will have external customers in need of insight into the status of those systems. If we have business-to-business connections with systems or of our partners, our vendors, our suppliers, well then they may also have those to us. We need to understand, and we need to be able to provide them insight so they can understand as well. If their system is down, we want to know. If our system is down or is having challenges, we want for them to know so they can take appropriate action, just like we want to take appropriate action. You may be obligated to report specific incidents and their details to government regulators within a specific time frame. There may be penalties involved. You may be obligated to report to an accreditation organization to maintain an accreditation, or you may have obligations to an industry organization. These may also be places where we have to share insights. All right, so let's differentiate between our customers. Let's differentiate between the customers of our business and our customers within our business, and who are going to provide insights and to observability outcomes. We can look at things in terms of accounting. They're interested in payroll, especially on payday, but they're also interested in accounts receivable and accounts payable. They're interested in finance. Let's look at some other personas. What about our developers? They're specifically interested in the conditions of the workloads they themselves developed, the health of the things they've created. We want to identify our personas, our consumers, by role, by area of interest, by what they need. And while not in this table, it's best to get their name and their contact information. After all, we're trying to fulfill requirements for them. Some may have very narrow focus areas, and some may have extremely broad. Now that we know who has need of insight, we need to understand the business outcomes we are supporting. Senior leadership sets the priorities, and from those, targeted outcomes are determined. Understanding the goals associated with those outcomes and determining what the key indicators of success are is our activity. KPIs are neither good nor bad. They just are. The SMART test should apply. They should be specific, measurable, achievable, relevant, and timely. Let's look at the first one up there. We want our customer to have a quality experience. We want them to be able to access the site. If we have a retail site, we really want them to be able to access the site. So our KPI in this case is site availability. Let's look some more. Let's take a look at the last two on this one. Timely vulnerability management is our business outcome. Our goals is to identify vulnerabilities in our environment. Our other goal is to mitigate the vulnerabilities in our environment, and so it makes sense that our KPIs would be related to the time to identify and the time to remediate. Vulnerabilities represent risk. Risk to the achievement of our outcomes, risk to our organization. We need to address them. All right, a brief side trip before we link to KPIs to our metrics. We've discussed telemetry at a high level. We understand what is available. We can consult the experts. We can look at the workload architecture. We can deal with the developers and the operations team members. If there is a need for additional telemetry, if we don't have what we need to achieve business outcomes, then implementing the necessary telemetry should be a priority, and the developers of the application are responsible to do that. This exercise, by the way, is an excellent way to capture the components of our workload, what's present in the environment, how they relate to each other. If we can't identify all the components, then we've identified another challenge. Traces, with their ability to discover the relationships between systems, can help with this challenge. Okay, let's link our KPIs to metrics. So we're specifically focused on our retail site at this time, and we're looking at its components and their parts. In the first example, we're creating a link between KPIs and the available telemetry. We're defining a metric threshold for what good looks like. In this case, we're looking at the average page load time. We want it to be less than 5 milliseconds. People get frustrated extremely quickly, and we want to give them a fast response. So how do we define a threshold? Well, I often get asked the question, what CPU utilization is acceptable? Is 85% CPU utilization okay? And my answer is, well, if you're running a transcoder, then you're not getting maximum performance out of it. There's 15% you're not using. If it's something like a domain controller, we might want to get security involved because that utilization is way too high for what we would expect. So I generally turn back the question onto the developer. I don't know. What CPU utilization is acceptable? After all, in moving the workload through the pipeline into production, testing should have occurred to profile the application and its needs. Thresholds are specific to a use case. They're based on the application itself, so transcoder versus LDAP. Now, the important thing here is don't worry about getting them wrong. I like to embrace the first wrong answer. I may not know what the answer is, but if I put something out there and it's wrong, people will tell me it's wrong, and they will correct me. So what we're putting out there may just be the first wrong answer, and we will iterate, especially once we get feedback from the consumers of the system. If the customer says it stinks, and we'll have to adjust the threshold and improve the workload. I like to think of thresholds in 3 ways. We know what good looks like. Do we know what bad looks like? If we're not good, are we bad? If we're not good, are we going to intervene, or are we just going to investigate? So the distance between what good looks like And action is something that is going to have to be a determination that you make. Over time, the other threshold we need to look at is when we're going to create improvement. When are we going to start to plan to make a change when trends are indicating that a challenge is emergent? So the three thresholds I like to talk about are investigation, intervention, and improvement. Let's see here. What we're really talking about next is time to action. Specifically, we're going to look at things where the action might not be immediate. Well, it won't be immediate, probably, and it probably won't even be in the near term. We're talking about reporting and trending. So when is the product of our insight going to be acted upon? What is the time horizon? If we have a 0-day vulnerability, if the retail site is vulnerable, it will be at risk. And it's a risk-based decision to actually fix the vulnerability if it's actively being used. We might have an architecture that can address this with minimal impact. But if we're looking at, let's see here. If we're looking at security controls and compliance status, we may have a dashboard that lets us know where the vulnerabilities are, and we might have a summary report we get monthly, letting us know that we're non-compliant. Dashboards can give us continuous information. They're point in time with some historical content, whatever is present in the dashboard. But I do find that still to this day, people like to receive a report and look at it all at once. So let's take a look here at our time horizons. So for that 0-day vulnerability, if we actually have performance trending going on, if we have understanding of our total utilization and our utilization over time, based on utilization, we might schedule improvements. But if we're in the situation where there's a 0-day vulnerability and we're having a conversation about risk management, I may, as the product owner, look at our total utilization, see what's active on my system, and then we'll make a decision about whether it's more costly to interrupt those activities, or is it better to address the vulnerability now? So we're looking at the current status and the ongoing status. We're looking at the reports. We're looking at the trends. We're addressing an issue at the speed of a human being having a conversation. And then we're planning to do the work following that. Our time horizons with reporting are very long. With trending, they're very long. We may have lots of headroom in our trends before we actually need to take action. All right. What about when the time to action is near immediate or extremely near term? Let's take a look at alerts and actions. Here we're looking at a focus area, trying to identify what specifically we're going to act on. We're looking at it in terms of the insights we have, or the areas we're focused on. We're talking about criticality. Now, what's criticality? What's it for? Well, criticality is a way to give a relative comparison between two things. So specifically, if it's high criticality, or the higher the criticality, the more priority it should have. At the highest criticality, the issues in the environment should be addressed first. So right here, the retail site's not available. That's critical, right? And we're going to take action immediately. If we're going to alert on something, there must be a defined action behind it. Otherwise, we're just creating noise. And we need to know who owns that action. So if the retail site is not available, Ops is going to investigate the incident, identify the fault, and work to resolve the issue immediately. If one of our web servers tries to connect to a Bitcoin masternode, something is probably up and security needs to investigate it. So for that alert, connections out to a Bitcoin masternode, the owner is security, and the action is to perform the security incident response. Now, they can isolate it. They can address more critical issues like active compromises, but that should be addressed. All right, it's a priority. It's medium, but we'll come back to that. All right, here are some events that can happen that do not merit an alert. So if we have an unhealthy instance in an autoscaling group, we don't need an alert. The autoscaling group is going to automatically replace the instance. If there have been multiple failed login attempts for a user on a single account over a few minutes, and it was eventually successful, or they did a password reset, we don't need to alert on that. Now, if that was 10,000 failed login attempts in the equivalent time period, that's a security event. So things are relative. If we're exceeding a budget, we're trending to exceed our budget, well, we need to determine why, we need to take action, but the trend to exceed our budget in the short term, in the month or the week, we don't need to alert on that. That can be taken at the pace of a human being, taking time, considering, getting data, figuring out why, and then taking action. All right. How important this? When the time to action is immediate or really soon, how do we choose which of our priorities to do first? Here is my simple approach to it. Okay, critical. Without this, we can't operate the business, or the impact from it will cause grievous harm. With high, this greatly harms our ability to perform business, or the impact is, well, significant or broad. Medium, this is important. Not like high or critical, but it's still important. The impact is there, but not debilitating. Non-critical, it has little impact. Perhaps it's a system that's infrequently used, or it just isn't that important. And then low is essentially inconsequential. Here's the sanity test. Let's check to see if we've applied appropriate values. When is lunch? All right, what if you're the only person working the issue? Critical, the issue needs to be worked until complete, and additional resources should be engaged to also work the issue if they're available. If there's going to be a transition between people working on the issue, there should be a warm handoff so that we ensure that there is continuity of knowledge and people know what next steps should be taken. If it's high, the issue needs to be worked until complete, and warm handoffs are also required. If it's medium, the issue needs to be the focus of work during core hours. Maybe if there's multiple shifts, hand it off to the next shift. Otherwise, maybe we'll pick it up tomorrow. If it's not critical, then a single person can work on it. Maybe they'll not work on it constantly, but it will get consistent attention from them. If it's low, it might not ever get attention unless nothing else is an issue in the environment. So when's lunch? Critical? Why are you talking about lunch at 3 a.m.? High? Gonna have to order food. Maybe I'll be eating while I work. Medium, I'll eat at my desk. Non-critical, I'll work on this after lunch. And low, maybe a long lunch. All right, what have we learned? Well, we've learned why you need a monitoring strategy, what it is, the difference between observability and monitoring, and how to develop your monitoring strategy. We've established a simple mechanism to build our strategy, focusing on the people, the business outcomes, the KPIs, our sources of insight, and establishing thresholds for investigation, intervention, and improvement. We've looked at time to action. We've looked at alerts, which definitely need to have an owner and definitely need to have an activity that's going to be performed in response, or else they're just noise. We've talked about criticality in the simplest way possible. When are we going to eat, or do we get to? And the output of that effort is the plan for implementing monitoring. All right, here's some helpful resources. This is the Observability 1 demo. It's at observability.workshop.aws, and it's got tons of the observability and monitoring services, lab content for them, so you can explore, try them out for yourself, learn how to use them. And I am from Well Architected, and we do have some Well Architected resources like the AWS Well Architected Framework, which has the 5 pillars. It has lenses, which are domain or technology specific guidance. We have the Well Architected Labs. They're open source. They're on GitHub. It's your chance to grab some labs, run them in your own account, and apply some of those best practices. Learn more about how to do it. The AWS Architecture Center pulls all these things together, including the AWS Solutions Library, which is a set of patterns and commonly adopted services implemented using well-architected practices and principles. Thank you. I appreciate your time today. I am Brian Carlson, the Operational Excellence Lead for Well Architected, and I guess the next thing to ask is, are there any questions?
Exactly so. Are there any questions? Joined live from Brian, who is somewhere in the Eastern Standard Time Zone. Brian, whereabouts in the States are you?
I'm just outside of Washington, D.C.
Gotcha. And what time is it for you there?
It is 2:16 p.m.
Gotcha. Very nice. So we've been doing a lot of well architected stuff. My business has been involved in that since April 2018, through the sort of partner sharing of that program. Operations tends to be, I think, in our experience, the least well taken care of pillar of the five. Why do you think that is?
Well, I think the other four pillars are primarily non-functional requirements. So there's something that comes up as a matter of course. There's also a challenge there where people would prefer to do the functional requirements because they deliver direct value to the customer. But with the non-functional requirements, specifically security and reliability, if you don't have security, you don't have trust and you won't have customers. If you don't have reliability, you can't serve your customers and you won't have customers. So those get a lot more focus. And with operations, it's a lot of things people have to choose to do. They have to make decisions, they have to be informed, and then execute a process. And that's way harder to do than implementing an appropriate non-functional requirement.
Gotcha. Yeah, I have this sort of pet theory that we're sort of optimists about the things that we build, and operations requires us to be pessimists in a way, or at least structure our thinking pessimistically for a period of time in order to understand like how we would deal with failure. Would you consider yourself to be a pessimist, given your sort of choice of angle of career?
No, not at all. Absolutely not. But I still want to make plans just in case. Is that fair?
I think that's fair. So, how long would you say, like, maybe as a percentage of like the amount of time that you spend building a thing, how long as a percentage of that time should you be spending thinking about those failure modes and thinking about telemetry and so forth?
Oh, that's a really interesting question. If you think about the development cycle, once you're done, or if you're ever done, there's a really long tail behind that, right? You want the thing you build to last a very long time. And the thing that's going to keep it going whenever there's an issue is operations. So you ought to make a significant investment, ideally up front. Because if you're thinking about operations while you're building it, then you're building in what you need to operate it. So as a percentage, depending on the complexity, that's going to vary, but you spend 10 to 15% of your time up front trying to address that, you're going to get value out of it, especially during that long tail of operations.
Yeah, gotcha. Just for the benefit of the people on the stream, you can, of course, ask Brian questions in the Twitch chat if you'd like. Brian, you sort of asked yourself a question a little bit, almost, which I'm going to pick up on, which is like you asked if anybody's having a challenge knowing what their components are. Is that something that you've seen people struggle with?
Very frequently, yes. In highly complex systems with lots of microservices, you might not actually recognize that you have a dependency on something that you call to. And do you consider that part of the system or not? So if it's a dependency, you need to be aware if it's part of your system function, or if you want to put a circle around what your actual workload is, then where do you put that? And understanding what's inside that circle, yeah, people struggle with that.
So would you think of individual lambdas, for example, in a serverless setup as individual components, or would you think of, I guess, groups of lambdas as a component? How would I make the distinction between the two?
I think you have to deal with them individually because you would address issues with them individually. So your collection of lambdas, if it's the same function, okay, we'll call that one component. If they're different functions with different activities, we have to think of them as a separate component.
Yeah, gotcha. I think you talked in the sort of remediation part of the talk about, I guess, sort of informing humans about something going on. Well, architecture sort of talks quite a lot about the automated remediation of things that come up. Is that something that you see a lot of in the field, or is it something that you would like to see more of instead?
Are you talking about automated correction of like a configuration or something to that degree?
Yeah, or I guess your telemetry has picked up that there is this particular fault, and you sort of know that there's a way of getting around that fault, and so you've spent time orchestrating something in Lambdas or whatever to make that happen.
Yeah, if you actually understand how something fails and a person knows how to fix it, then automating that is the wise choice, because that way your response is at the speed of the event, the recognition of the event, and the initiation of the remediation. So yeah, people should definitely perform that automation if possible. After all, once they do that, they don't have to deal with that issue anymore, and they can focus on other things that are going to deliver additional value.
Yeah.
So yeah.
I guess that's always the struggle with certainly with smaller teams is that kind of the balance of do I spend those hours on a feature that might make me some money, or do I spend those hours on remediating the potential thing that might fail one day?
If you're familiar with XKCD, he has an excellent comic on the merit of automation, whether or not the time investment is worth it. I wish I had that at hand right now.
Yes, I know the one you're thinking of. There is almost an XKCD comic for pretty much everything, isn't there?
It's an excellent reference site. It's definitely worth looking at frequently.
Our office wall has our Wi-Fi guest password up on it, which is of course correct horse battery staple, because why would it not be? So Alex in the chat is asking, do you have any recommendations on managing dependencies? In today's distributed microservices world, it's very unlikely that the individual components are managed by multiple teams and will not be aware of the dependency unless there is an incident.
That's a very interesting question. All right, so let's look at that in two different ways. You have to have awareness of your dependencies in order to understand if there is a failure there. So if you have the ability to use traces, or that certainly makes it easier. If you can discover them in your architecture, that certainly helps as well. But you have to be responsible for understanding what your dependencies are, even if they're within the same organization. At the same time, ideally, the people who are providing you the services, the people who provide you what that dependency is, they should be aware of you as well. So the management responsibility ends up being bidirectional. Let's see here. On how to manage the dependency, I prefer to monitor for them regardless to understand the state. Occasionally, I'm the person that tells the person who provides me the dependency that they're actually down. That's really awkward, but would you rather not know and suffer what a service provider is providing for you, or would you rather make sure that you're aware of it yourself and take action? So with those dependencies, I would make sure that I was able to measure their impact on my workload and then respond appropriately.
Gotcha. Yeah, there's some good stuff from the Financial Times, the FT over here in the UK. If you have a look for some of their talks on microservices, they talk about a sort of central catalog or maybe a metadata format for every repo that has the kind of the foundations of what do I depend on, who is the person that I will wake up if this goes wrong in the middle of the night, what are the sort of operational characteristics, and that seems to go quite a long way to helping them find their way around incidents like that. But it also seems to be the case that an incident might actually wake up a lot of people in that sort of dependency chain, where the sort of the place where the incident looks like it's happening actually isn't where it's happening, and you sort of cross a team boundary in order to have to solve the problem, and then you've eventually woken up the entire ops team because like it's touched every part of the system.
There's another way to look at that dependency as well. If your application can actually track its success and do retries, super helpful. If you can see the response rate of your attempts to connect to the system, that's also helpful. I want to provide one caution here, though. If you're consuming a microservice and you are doing retries, make sure that you implement jitter so that if it's failing based on load and you've made 1,000 outstanding requests, when you make those requests again, you're likely to crush that microservice. So implement jitter so your retries are staggered, ideally randomly, so you don't end up killing off the dependency by trying to recover use of the dependency.
Yeah, that sort of retry logic and back off and so forth. It also seems to be the sort of thing that maybe doesn't get built into services as a default. It's the sort of thing that gets added after sort of hard-won lessons or hard-earned lessons about that sort of thing. It's interesting to sort of a lot of the microservices literature talks about things like back off and circuit breakers and that sort of stuff, but it's sadly a little rare to see those things implemented from like the early days of a product. They seem like the sort of things that you would build into your framework or kind of rationalize in some central way as you start building the software. But I guess you only do that if you've been on an operations team, right? I firmly believe that people writing software should be in a support rotation at some point.
I have to agree there.
Reasons.
Yeah, it's ideal if your developers are actually aware of the performance of their system, then they can be part of the solution when something goes wrong. In fact, when you mandate that they're part of the solution as a part of the tier 3 response, if you're starting with someone who's just your point of contact who has issues, that the ops engineers, if the developer's up there, then your responses are likely to be much more effective and efficient. And if they also get be woken up at 3 a.m., I suspect you might get fewer issues that actually persist in production. I'm not saying there's any specific reason why, but who wants to get woken up at 3 a.m.?
Absolutely, yeah, or a few missed lunches, or at least or something like that. So I know you're an AWS insider, which means that you maybe know some of the things that are going to be announced at reInvent. But I also know that that's not necessarily true because of how the unique way in which AWS is constructed as an organisation. So, of the things that you don't already know about, is there anything on your wish list particularly?
Well, that's an interesting question. I don't even know if I should speculate in this space.
I mean, it is public. I mean, we're going to put your neck on the line. It's going to be a YouTube video for Jeff to find.
I would feel terribly awkward if something I speculated about actually came to pass, because it might be asserted that I actually knew something and said something. What I really want, though, primarily is for best practices to be easier to adopt. So the more the service teams actually make the best practice or the default that goes with the adoption of the service, the better. So if I can see more of that at reInvent, I'll be very happy.
Yep, great stuff. Well, thanks for your talk, Brian. Thanks for sticking around and answering some questions.
Cheers.
Hang around again for a few minutes and join our panel. I'm going to go over and I'm going to announce the winners of the raffle. Thank you, Brian.